Good day, students. So welcome to part 3 of the Algebra 2 Trig Regents review for January 2014. In this installment, we're going to be going over problems 11 to 15. More clips can be found on mathgotserved.com/testprep under New York Regents. Let's go ahead and take a look at problem 11. So for problem 11, we are asked the roots of the equation 2x squared plus 4 equals 9x are. So in order to classify the roots, we do not actually have to find them. We'll simply make use of something known as the discriminant. Okay, the discriminant is the radicand component of the quadratic formula. If you think about the quadratic formula, is x equals negative b plus or minus the square root of b squared minus 4ac in this entire thing divided by 2a. Okay, so the radicand of the quadratic formula is known as a discriminant, and it can tell you what the nature of the root is going to look like. Okay, so the discriminant is b squared minus 4ac, where ax squared plus bx plus c is equal to 0. Remember, before finding ABC in your quadratic formula, your equation has to be in standard form, right? So that's why I wrote this remark here. Now let's look at the problem we have. 2x squared plus 4 equals 9x. Now, is this equation in standard form? The answer is no. It's not equal to 0, and the powers are not in descending order. So to accomplish that form, we're going to subtract 9x from both sides. And then that yields, let's see, 2x squared minus 9x plus 4 equals 0. All right, so this implies that A is 2, B is negative 9, and C is 4. Okay, so please make sure you write your equation in standard form first before you select A, B, and C. Someone might look at this equation and say, oh, this is A, B, C, and that's wrong. It has to be in standard form first, and then you can know what your A, B, and C are. Okay? All right, now that I have A, B, C, let's look for the discriminant. Discriminant, let me just call it this. Discriminant is equal to b squared minus 4ac. So when we substitute these values of A, B, C into our discriminant formula, we are going to have negative 9 quantity squared minus 4 times 2 times 4. Okay, negative 9 squared is 81. Because minus square is positive, minus 4 times 4 is 16 times 2 is 32. 81 minus 32 is 49. Okay? Now, one thing I want to notice is that this number is positive and is a perfect square. Now, how do we know when the roots of an equation is real, rational, and equal? Well, if the discriminant is equal to 0. Okay, the discriminant is equal to 0, you have real, rational, and equal roots. Is this equal to 0? Nope, so this is not the answer. When do we have real, rational, and unequal? We have real, rational, and unequal roots when this radicand component can be simplified into a rational number, okay? And that happens only when the discriminant is, first of all, greater than 0, so it's real. That's the real part. And the discriminant is a square, a perfect square, or just a square, All right, a square like 9, 4, 16. Okay, how is it? When is it real, irrational, and unequal? It's real, irrational, and unequal when the discriminant is greater than 0, which means you're taking the square root of a positive number, which guarantees your output to be real, and is not a square, not a square. Okay, so any number that's not a square, when you take the square root, you have an irrational number. Okay, when is it imaginary? Well, when the discriminant is negative or less than 0. Remember, when you take the square root of -1 or any negative number, you have an imaginary output. So which of these scenarios applies to this? This number is positive, so it cannot be imaginary. it's um, a perfect square. Okay, since this is a perfect square, that means we're going to have real, rational, and unequal roots. So our answer is option number 2. Okay? All right, let's move on to number 12. So for number 12, it says, if d varies inversely as t and d is equal to 20, when t is equal to 2, what is the value of t when d is equal to negative 5? So if you see a situation with inverse variation, so d varying inversely with t, we're just simply going to use the formula d is equal to k over t. Okay? So as d gets bigger, t gets smaller. As t gets smaller, d gets bigger. That goes your inverse variation, where k is a constant of proportionality. K is a constant. So k doesn't change regardless of the alteration in the values of d or k or t. Okay? So in order for us to solve an inverse variation problem, we have to first of all find k, since it will help us to solve for one variable given the other. So how do we find k? We'll use the first piece of information here to set up an equation in one unknown, namely k, and solve for k. Okay? So d is equal to 20, t is equal to 2, k is equal to what? What is k? We have no idea. So this setup will help us find k. Okay, so we apply these values to our formula and solve for k. Okay, so let's do this. We have 20, which is d is equal to k, which we do not know, over t, which is 2. So to solve for k, we just simply multiply both sides by 2. And then our final answer, k, is going to be 2 times 20, 40. All right, now that we have k, we have a new set of values for d and t. Well, we're given the new d value, and we have to find t. Okay, now for the next case, d is no more 20. D has changed. D has basically reduced drastically. So d is equal to negative 5. T is, now what is t now? T, we do not know what the t is because d has changed and is going to impact t. How about k? Remember, k is always constant. Okay, so k is always 40 regardless of the change in these two. All right, so now let's go ahead and solve the equation again using the same formula. D is negative 5 equals k, which is 40 over t. Okay, to solve for t, we can multiply both sides by t. Multiply both sides by t. We'll have negative 5t is equal to 40. And divide both sides by negative 5. And that yields the value of t, which equals negative 8. Alright, so t is equal to negative 8. And our answer for number 2 is option number 3. Okay? Alright, let's move along. Alright, so for number 13, it says if sine A is equal to negative 7 over 25 and angle A terminates in quadrant 4, tan A equals. So we have to first of all graph the angle in standard position first. Let's go ahead and graph it. We're in quadrant 4. So we also have to pay close attention to the signs of our axis and also how we label the triangle. So that's why this is positive, negative, positive, negative. This is x. This is positive x and negative x. All right. Let's go ahead and draw the angle. It's just a sketch, okay? But it has to be in standard position. So we have the angle like that. There goes the angle. All right, A is in standard position, so it has to go from the terminal side to the x-axis. So this, let's draw that again. This angle right here, that's A, okay? All right, now how can we use this information to populate the size of this triangle? Well, since it's right triangle tree, we can make use of something known as SOHCAHTOA. Okay, this shows the relationship between an angle and the sides of a right triangle. Now let's label our triangle right here. This is the, since this is the angle given, this side right here is your opposite, okay? Oh, this is your hypotenuse, H, and this is your adjacent, A. All right, what does so tell us? So tells us that sine of the angle, sine theta, is equal to opposite of a hypotenuse. And we also know that from the given problem, sine A is equal to -7 over 25. So which is which? What is what here? Since opposite and numerator is in the numerator, we can tell that this numerator piece is the opposite, and this denominator is the hypotenuse. Remember, the hypotenuse is always positive, so the opposite is -7, and the hypotenuse is 25. So let's populate our triangle with these measures that we determined. So the opposite is -7. So that's where your opposite is. Let's go ahead and populate that measure in a triangle. Opposite is -7. Your hypotenuse is 25. And all right, so now we're looking for tan, okay? We have to find the value of tan A. So let's write down the trig ratio for that. If you look at SOHCAHTOA, what does TOA tell us? TOA tells us that tan of an angle, tan theta is equal to opposite over adjacent, okay? All right, so in this problem, tan A is going to be the opposite, which is -7 over our adjacent. What is our adjacent? We do not know. So how do we find it? How do you find a missing side of a right triangle given two sides? You make use of the Pythagorean theorem, okay? So remember the Pythagorean theorem, a squared plus b squared equals c squared. The sum of the square of the legs equals the square of the hypotenuse, okay? So we can also write this using this opposite, adjacent, and hypotenuse. We can write this as adjacent square plus opposite square. These are the legs. This is a leg, that's a leg, equals to the hypotenuse square. All right, let's go ahead and solve this. We have adjacent, we do not know, so let's leave it as a square plus opposite, -7 square, equals the hypotenuse, which is 25 square. We remember what we're looking for. We're trying to find a. Okay, so we have a square plus 49 equals 625. And then if we get a squared by itself, a squared is going to be 576. And then if you root both sides, a is equal to 24. Okay, so a is 24, positive 24. So we know what our adjacent is using SOHCAHTOA. Tan a is now going to be -7 over 24. So we can clearly see that our answer for 13 is option number 2. All right, let's move on to the next problem. Problem 14, we have to find which expression is equivalent to the discrete sum from 1 to 4 of a minus n squared. So all we're just going to do is, we know that n is going to attain 4 values. N is going to be equal to 1, 2, 3, and 4. So using this indexing system, we're going to generate 4 values for this expression, and this sigma means that we should sum all of them. Okay, all right, so let's go ahead and do it. For n equals, so this is your start, this is where you're going to start. Okay, start plugging in, and this is where you're going to stop. So when n is equal to 1, we're evaluating the values of n for the expression a minus n quantity squared. So when n is equal to 1, we're going to have a minus 1 squared. Now what's a minus 1 squared? There's a form I'm going to be using here, which is a minus b squared. If you square that, it's a squared minus 2ab plus b squared. This is a shortcut to foiling, okay? So I'm going to use that here since I'm going to be doing this 4 times and I don't want to waste too much time. So a minus 1 squared is going to be a squared, which is a squared minus 2ab, which is 2a plus b squared plus 1. All right, for and n is 2. If this formula doesn't make sense to you, you can just FOIL it out. Okay, FOIL it out, you get the same thing. It just takes longer. All right, n equals 2, we have a minus, what do we have here? N is now 2, so it's a minus 2 quantity square. Using this formula, we're going to have a squared minus 2ab. B is 4 here, so it's going to be minus 2 times 2 times a, which is 4a, plus b squared, 2 squared is 4. For n equals 3, we're going to have a minus 3 squared. Using the same formula again, a squared minus 2ab minus 6a plus b squared, which is 9. And then for n equals 4, we're going to have a minus 4 quantity squared. Applying the same formula, we have a squared minus 8a plus 16. So what are we going to do with all these terms? Sigma asks us to find the sum. That's what sigma means, find the sum, okay? So let's go ahead and sum that up. We're just going to add it vertically. So for the a squares, just imagine that there's a 1 in front of all of these, right? So if you add it all up, you have 4a squared. And then 2 plus 4 is 2 plus 4, 6. 6 plus 6 is 12. 12 plus 8 is 20. But since all the signs are minus, you add and keep the sign, negative 20a, plus 5 plus 9 is 14. 14 plus 16 is 30. So that's the answer. All right, you can clearly see that our answer is option number 4. All right, let's move on to the last problem in this installment. We are asked what are the coordinates of the center of a circle whose equation is x squared plus y squared minus 16x plus 6y plus 53 equals 0. This is basically testing our ability to convert the general form of the equation of a circle into its standard form, okay? As a standard coordinate geometry procedure. So we have x squared plus y squared minus 16x plus 16y plus 53 equals 0. We need to create two squares here, two perfect squares. So in order to do that, we have to group our variables together. X squared minus 16x plus y squared plus 6y. Now, since this is a constant, it neither belongs to the x nor the y group. So we're going to move it over to the other side by subtracting 53 from both sides. All right, so this is going to be equal to negative 53. All right, now let's divvy up our worlds. We have the x world and the y world. We have two incomplete squares. We now have to complete the square. To complete the square, you simply add b over 2 squared to both sides of our partition. So we have, this is a in the x world, and then this is b in the x world. This is a in the y world, and then this is b in the y world. Okay, let me change colors here so we can delineate what we're doing. So I'm gonna let the b's be green. All right, so let's see, how do we do this? A and the y world is supposed to be y. So let's do the x world first. So we want to complete the square in the x world. So b of x is equal to negative 16. So and then in the y world, b of y is equal to 6. Okay? All right. So to do this, let me just set it up so it's easy for you to understand. You have x squared minus 16x plus a number that completes the square in the x world. We're going to create a perfect square trinomial here. In the y world, y squared plus 6y plus a number that completes the square in the y world equals negative 53. Now, since we introduced two numbers to the left side of the equality, to preserve equality, we must add two numbers to the right side also. Okay? All right, so what are the two numbers that helps complete the square in both worlds? Let's do the x one first. For the x world, we are going to simply do b over 2 square, okay? Twice. So in the x world, b over 2 divided by 2 is going to be equal to negative 8. And when you square that, you get 64. So put 64 here. That makes this a perfect square trinomial. So you also add 64 on the right side of the equation. to preserve equality. b of y is 6, same procedure, divided by 2. b of y over 2, which is 3. When you square that, you get 9. So by adding 9 here, we have a perfect square trinomial. To preserve equality in our equation, we have to add a 9 here also. Now, how do you factor perfect square trinomials? You can factor by grouping or use a shortcut. I'm going to be using the shortcut in this problem. Okay, so to factor this quickly, you just root the first and the last term and bring down the middle sign, and that yields x minus 8 quantity square. Okay, plus. Same story for the y world. You root the first and the last term, and then you're going to have y plus 3 quantity square equals 20. Okay, so equals 20. All right, so all we care about is the center. So the center is hk. So the standard form of the equation of a circle is, let me write it down here, is x minus h square plus y minus k square equals r square. The center is hk. Okay, so we just basically take the number next to the x, you do the opposite for the x coordinate, and the number next to the y, we'll do the opposite. Okay, this minus in front of the h and k tells us that we must do that. Okay, so the center is going to be, since you have for the x coordinate in negative 8 here, we'll take the opposite, positive 8, and at positive 3 here, we'll take the opposite, negative 3, and there goes your center. The correct answer is option number 3. Okay. So thanks so much for taking the time to watch this presentation. We really appreciate it. Feel free to subscribe to our channel for updates to the rest of the installments in this review series. Do give us a thumbs up if you like this presentation. It will be appreciated. And feel free to view more clips on mathgotserved.com/testprep under New York Regents. Thanks again for watching, and have a wonderful day.